Hey everyone, welcome to today's session on version control systems fundamentals. This is part of our series Technology for Project Managers, where we try to break down technical concepts for everyone and especially for non technical managers. So, think of version control as the kind of backbone for developing software. It's not just about storing code, it's about enabling the collaboration, ensuring accountability, and maintaining code integrity. By the end of this session, you'll not only understand how developers use these tools, but also why managers or project managers need to care about this version control process. So let's get started. So, at first, why do we care about version control? So, poor version control practices can lead to lost work, overwrites, or hours wasted debugging because no one knows what exactly has changed or who changed what. Without a proper system, collaboration becomes chaotic. Developers struggle to share files, merge changes, and track history. And here's something important: shared terminology. If a developer says commit or branch, and as a project manager you are unfamiliar with these terms, it creates communication gaps. Knowing these terms helps you to understand the project terminology, workflows, and even status updates. So, version control isn't just a developer problem, it's a project success factor for everyone. Let's dive in. Now, let's set the foundation. So, what exactly is version control? At its core, the version control system records changes to files over time. The version control system records changes to files over time. It lets multiple people collaborate on the same project, experiment, and even roll back to a stable version when something goes wrong. The benefits are huge. You can track every change. Developers can work in parallel without blocking each other. You can always return to a previous working state. Some common tools you'll hear about here are Git, SVN, or Mercurial. Among these, Git has become the industry standard, and that's what we'll focus on in this session. But before we go deeper into Git, we need to understand the two main models of version control, or two variations per se: centralized and distributed. Centralized systems like SVN, they rely on a single central server. This makes them easier to understand and control, but they have some drawbacks. The single server is a single point of failure, and branching or merging is often painful. Distributed systems like Git, they take a different approach. Every user has a complete copy of the repository, so you can work offline, branch freely, and collaborate more efficiently. But the trade off here is a steeper learning curve and a bit more complexity. Think of centralized systems as a library where only one master copy of the book exists, and distributed systems as every reader having their own complete copy with the ability to merge updates later. We'll keep this in mind as we explore Git further. Let's talk through some basic Git commands. Clone. This copy is a project from a remote repository into your local machine. Create a branch. This lets you isolate work so changes don't disrupt the main project. Add and commit. This is like saving your work with a description of what you did. Push. This shares your changes back to the remote repository, making them available for the team. Think of it as drafting an email. You write your content, review it, hit save, and finally send it to the group. That's essentially how Git workflow looks. As a project manager, when you hear developers talk about pushing changes or working on a branch, you'll know exactly what they mean. Let's move on. So how do we actually get started with Git? First, there is a setup, configuring your name, email, preferences. This ensures all commits are traceable. Then you create a repository, which is basically project folder under Git's control. From there, the workflow is simple. Make changes, stage them with Git add, commit with a meaningful message, and finally share them with the team using Git push. Git also brings unique features like lightweight branching, a staging area, and complete offline history. These may sound technical, but as a project manager, what matters is understanding that Git enables speed, flexibility, and traceability to your code. Now that we have the basics, let's talk about how teams organize their work using branching strategies. Branching is where Git really shines. It allows teams to work on features, fixes, or experiments without affecting the main code. These are the different strategies. Gitflow, which has a structured branch types like main, develop, feature, release, and hotfix. Feature branching, which is simpler. Developers create feature branches from the main branch and merge them back when they are ready. Trunk-based development. This is where developers work directly on the main branch, which with very short-lived branches. Choosing the right approach depends on your release cadence, team size, and product complexity. Larger enterprises with large projects, they might prefer Gitflow, where smaller web teams often succeed with feature branching or trunk-based development. Knowing which model your team uses helps you understand timelines, dependencies, and points of risk during integration. And this connects perfectly to our next topic, making sure every commit, every saved change is meaningful and traceable. Let's look at commit best practices. Now that we have covered branching strategies, let's talk about the next building block, commits. Think of commits as snapshots of progress. Each commit should represent a logical unit of work, something that tells a clear story. A good commit message is specific, short, and written in an imperative mood. For example, instead of writing added login form, you would say add login form. This makes the history read like a list of actions. Clear commit history is a gift not only for developers but also for managers or any other stakeholders. Why? Because when something breaks, you can quickly trace to what has changed, when, and why. And that brings us to the next important decision developers face. Should they merge or rebase? Merging and rebasing are two ways of combining code from different branches. Merging creates a new commit that brings two lines of history together. It's non-destructive, but the history can look messy. Rebasing rewrites history, placing your work on top of the main branch. It creates a clean, linear history, but it changes commit IDs and can be tricky for shared branches. The golden rule here is rebase your own local branches to keep things tidy, but merge when you're working with shared branches to avoid rewriting history that others rely on. You don't need to execute these commands yourself as a project manager, but knowing the difference helps you understand why a pull request may take longer or why conflicts arise. And speaking about conflicts, let's talk more about what are these code conflicts. Conflicts happen when two developers change the same part of file in different ways, and Git isn't sure which version to keep. You'll often see conflicts markers in files, and resolving them can be frustrating if the history isn't clear. Developers resolve conflicts manually by choosing one version or with visual merge tools. But as managers, your role is to help minimize them. Encourage your teams to pull updates frequently. Keep commits small and focused. Clearly define ownership of files and communicate early when working on overlapping areas. Less conflicts means smoother integrations and less time wasted during crunch moments. Now let's take a step back and look at the big picture. How do we manage different versions of an application? In Git, we use tags to mark specific points in history like a bookmark. Tags don't move around like branches do. They stay fixed to a particular commit. Release builds on that by packaging not just code, but also artifacts like binaries and release notes. This distinction matters. Developers may code tag internally, but as project managers, you're often involved in coordinating releases. Ensure the right version gets tested, documented, and shipped. A consistent tagging and release process builds trust with users and makes support far easier. Some of the best practices for versioning, specifically semantic versioning. You'll probably have seen numbers like 2.4.1. Here's what they mean. Major, big changes that breaks compatibility. Minor releases means new features which are backward compatible. Patches are bug fixes, also backward compatible. For example, moving from version 2.4.1 to 2.5.0 means new features are added, and moving 2.4.1 to 3.0.0 signals major changes that might require users to upgrade. Semantic versioning helps manage dependencies, it improves release planning, and it sets clear expectations for users. So when version numbers aren't random, these actually tell a story about the evolution of the product. Let's talk about something called as hooks. Hooks are scripts that run automatically at certain points in a Git's workflow. For example, a pre-commit hook might check if your code passes the test before allowing you to commit. A commit message hook might enforce consistent commit messages. On the server side, a pre-receive hook could block changes that don't meet review requirements. The point is, hook lets teams enforce standards and automate checks right inside the version control system. This means less manual policing and more built-in quality control. Next, let's look at security of the code base. Not everyone should have the same level of access. At the simplest level, permissions are split into read, write, and admin. Teams often create roles and groups. For example, developers with write access, reviewers who can only approve, and external contributors who submit changes via pull requests. Best practices include protecting main branches, requiring reviews before merges, using signed commits, enforcing two-factor authentication, and scanning for secrets to prevent passwords or keys from leaking into repositories. Here's the key takeaway. A code base is an asset. Treat it with the same seriousness you treat sensitive business data. Once you have branching, commits, and access controls in place, the natural step is continuous integration, CI. In a CI/CD pipeline, Git becomes the trigger. Each new commit or pull request can automatically kick off builds, run tests, and even deploy to staging environments. A common workflow looks like this. Developer creates a feature branch, commits trigger automated tests, pull requests go through code review. After approval, the branch is merged. Merging into main triggers deployment. CI means faster feedback, fewer surprises late in the cycle, and more confidence in the frequent releases. Finally, let's touch these three advanced concepts like submodules, bisect, and reflog. Submodules. These let you include one repository inside another, useful when sharing libraries, for example. Bisect. This helps track down exactly which commit introduced a bug by testing commits in a binary search fashion. Reflog is like Git's black box. It records all reference updates and can rescue lost commits after a mistake. These tools aren't for everyday use, but they're powerful safety nets, problem solving aids. You don't need to master them, but knowing that they exist help you understand how your team recovers from setbacks or hunt down elusive bugs. Finally, let's bring these things together with some key takeaways. First, version control isn't just a developer tool, it's essential infrastructure. It underpins collaboration, quality assurance, and project management. Git has become the industry standard for a reason. Its distributed nature, flexible branching, and a huge ecosystem of tools make it fit for projects of all sizes. Remember that effective processes matter more than tools. It's not just about using Git, but about defining the right branching strategies, commit practices, and workflows that suit your team's maturity and needs. And then CI/CD pipelines. This amplifies the benefits. Automated testing, deployment, and quality checks all tied directly back to your repository. This creates a powerful and reliable delivery pipeline. The most important takeaway here is don't do everything at once. In case if you are starting with version control and CI/CD, implement these practices gradually, focusing on the most impactful changes first. And with that, we have covered the fundamentals of version control systems. I encourage you discuss these topics with your teams as you come across. And thank you for watching. See you in the next video.